So to make sense of much of the math we're going to be doing in our trigonometry unit, we need what's called the unit circle. The unit circle is centered at the origin, and it's a circle with a radius of 1. So notice that it goes through a y value of 1 here, x value of 1, y value of -1, x value of -1 there. So that is a unit circle. We're going to be plotting angles on this unit circle and then doing all kinds of math with those angles. It's helpful to know the names of the quadrants. So we actually number the quadrants starting with this sort of positive x, positive y quadrant. We call that one 1. And then we just number them going around the circle, but moving around counterclockwise. So that's 1, this is 2, this is 3, and this is 4. And we usually number them with Roman numerals. It's just kind of a tradition. All right, so you can plot angles on a unit circle. How this works is that you plot every angle from the x-axis. You draw a line on the positive x-axis. That's where we start every angle from. And then we measure the angles from there to what we call the terminal arm of the angle. So say I was doing 60 degrees. This angle in here looks like about 60 degrees. This is the positive x-axis here. And this is the terminal arm. That's this line right here. And then this is my angle, theta, which looks like about 60 degrees in that case. To measure positive angles, I go from the x-axis to the terminal arm in that direction, in the counterclockwise direction. So that makes a positive angle if you go from the x-axis to your terminal arm, rotating counterclockwise. A negative angle is if you start at the x-axis and you go backwards, you go this way. That's a negative angle if you go clockwise. So going that direction, you can also do it, it's just will make a negative angle. All right, so coterminal angles are angles that both start on the x-axis. Every angle will start on the x-axis here. And they end on the same terminal arm, but they get there in different ways. So I've got 2 drawn here. Beta 1 goes straight to my angle, looks like about 60 degrees. But beta 2 is going to go there backwards. So you can tell right away that beta 2 is going to be some negative angle. How you can calculate it is actually take beta 1, your initial angle, and subtract 360 degrees. And that gives you a coterminal angle, or an angle that also ends up on the same terminal arm. And in fact, the general rule for finding any coterminal angle is you can either add or subtract any multiple of 360 degrees to your original angle. Let's see if we can try this with an example. So here I've drawn 30 degrees. So that's the angle, there's my terminal arm. There's the positive x-axis. So 30 degrees is being measured from the x-axis to the terminal arm in the positive direction. That's the original angle I'm starting with. Now let's see if I can write down 2 other positive coterminal angles. Well, another thing I could have done, right, instead of just going straight there, so I could have started at the x-axis. Every angle starts at the x-axis. But I could have gone all the way around and then gotten to my terminal arm. So if I did that angle, what I'm really doing is beta 1, the initial 30 degrees, plus 360. Oh, sorry, that made a funny 6. Plus 360 degrees. And that would be, in our case, beta 1 is 30, so 360 plus 30 is going to be 390 degrees. Another angle you could have drawn is, I'll just erase this one so you've got more space, that's also positive, is I could have started at my x-axis here, because every angle has to start at the x-axis, could have gone around, gone past it, gone around again, and then reached my terminal arm. So in that case, what I did was I did beta 1 plus 360 plus another 360, so plus 360 times 2, and that gives me 750 degrees. So that's also coterminal with 30 degrees. Now what if I do some negative angles? So negative angles, I would still start at the x-axis here. To do the 2 negative angles, I'm going to go backwards. The first one I'll do just goes backwards right to that terminal arm, and that would be beta 1 minus 360 degrees to go backwards like that. So beta 1 is 30, 30 minus 360 is going to be negative 330 degrees. If I take negative 330 degrees backwards, that would also get me to the same terminal arm. You can also subtract multiples, though, of 360. So I could have started at the x-axis and then gone all the way around again, and still ended up at the same terminal arm. So that would be beta 1 minus 360 minus another 360, and that gives me, 30 minus 2 times 360. It's going to be negative 690 degrees. So those are 4 coterminal angles with 30 degrees. And you can just keep going. You could just add more 360s, right, or subtract more 360s to get more of them. All right, let's be a little bit more specific about how we describe the points on our unit circle. So these points all have an x and y value, right, because they're on an x and y grid here. But is there a way maybe that I can actually calculate exactly what x is and exactly what y is given some angle theta in here? Well, there actually is. What you can do is go from your point and draw a line straight down to the x-axis. And then I'll just draw the line along the x-axis as well. What you'll notice is you have a right angle triangle here. You have a right angle triangle with a radius of 1, or a hypotenuse of 1. This is actually the hypotenuse here, and that equals 1. If this is my angle in here, then the side opposite my angle must be this side, and the side adjacent to my angle would be here. So what you should notice is that that opposite side is actually just the y value, right? And the adjacent side is in fact just the x value, and the hypotenuse is always 1. So if I was trying to find an equation for x, I know the hypotenuse, it might make sense to use the cosine ratio of SOHCAHTOA. So we're actually going to use SOHCAHTOA here. So just write it out. So let's start with using the ca part. Cos of your angle is going to be the adjacent divided by the hypotenuse. And let's plug in what those things actually are. Cos of my angle is the adjacent, which is x, divided by the hypotenuse, which is 1. Look at that. That actually gives me a lovely equation for x here. X must just be equal to cos of theta, right? X divided by 1 is just x on its own. So x must equal cos theta. So that's a really nice equation for the x coordinate of that point on my unit circle right there. Let's see if we can do the same thing for y. So y is the opposite side, and I know the hypotenuse. So it might make sense to use the saw part of SOHCAHTOA. So sine of my angle is the opposite over the hypotenuse. But for us here, the opposite side is in fact y, and the hypotenuse is 1. And so y divided by 1 is just y. So that gives me a really lovely equation for y. Y is equal to sine of whatever angle I have in here. So the y coordinate of that point on the unit circle must just be sine of my angle there. So these two formulas are going to be things you'll definitely want to remember. The x coordinate is cos of your angle, and the y coordinate is sine of your angle. You'll want to memorize those because you'll use them a lot. Let's try that out with just some examples. Let's say your angle is 60 degrees. So that kind of looks like this, right? There's my x-axis, there's my terminal arm. If I wanted to know the coordinates of this point here, right? That point has x, y coordinates. Then the x part is going to be cos of 60, and the y part is going to be sine of 60. And you can just plug those into your calculator. So cos of 60 is 0.5, and sine of 60 is 0.866. So my point must be x 0.5, comma y 0.866. So this actually works for every angle. It doesn't just work for angles within the first quadrant. It actually works for any angle on your unit circle, even angles that don't appear to be part of a triangle. So 180 degrees looks like this, right? There's the positive x-axis. we rotate 180 degrees, we would be right here. That would be my terminal arm. That's 180 degrees. So that doesn't look like a triangle at all, but if I want to find the value of this point here, I can use the same process. You can look at it on the graph and you can tell pretty quickly, right, that value looks like it's going to be -1 for x and 0 for y, and that is right. Let's use this process here to make sure that's true. X should be equal to cos of my angle, so cos of 180. Plug that in, oops, cos of 180 is in fact -1. Y should be equal to sine of my angle, so sine of 180. Plug that into your calculator, sine of 180 is indeed 0. And so your point is -1, 0. What about tan though? So what I found out is that this point here on the end of my terminal arm, whatever angle I'm at, is cos theta comma sine theta, right? The x part is cos theta, the y part is sine theta. But is there an equation for tan theta in here? Well, it turns out there is. Let's draw that triangle again. So we'll draw our line straight down, draw a line over here. And that is a right angle in there. And we just found out that the y part here is sine of theta. So this is sine theta here. And the x part here is cos of theta. And we still know the hypotenuse, right? The hypotenuse is still 1 because that's the radius of my circle. What if we wrote down the TOA part of SOHCAHTOA? So here's, oops, forgot the C and then I spelled it wrong. Okay, here we go. SOHCAHTOA, there we go. Let's write down the TOA part of SOHCAHTOA. So tan of theta is going to be your opposite side divided by the adjacent side. But for us, if this is our angle theta in here, then the opposite side is the y value, so that's sine of theta. And the adjacent side is the x value, which is cos of theta. So if I want to know tan of theta, all I have to do is actually just take sine of my angle, divide by cos of my angle, and that will give me tan of my angle. This is a really handy trigonometric identity, it's called, and we're going to use this one a lot as we go through this unit. Last thing we're going to look at is just where is sine of theta, cos of theta, and tan of theta positive, and where is it, of course, negative. So remember that sine of theta is y, so y equals sine of theta. So when you're trying to figure out where is sine of an angle positive, well, it would be anywhere where the y values are positive. And you can see that the y-axis is positive up here, so it must be quadrant 1 and quadrant 2 must be positive for sine. And as we go down here, we get into negative y values, so that must be a negative sign, that must be a negative sign down there. So any angle in those top two quadrants, so anything between 0 and 180, so if theta is between, say, 0 and 180 degrees, then sine of theta will be positive. And if it's between 180 and 360 degrees, sine of theta will be negative. And that pattern will continue if you go around twice. If you go greater than 360 degrees, or if you do negatives as well, right? Any angle up here in the top two quadrants will have a positive sine value, and any angle in the bottom two quadrants will have a negative sine value. What about cos? So remember, cos is x. X is equal to cos of theta. So if I look along my x-axis, well, the x-axis is positive over here. So that means cos must be positive here or down here. And the x-axis is negative over here, so cos must be negative there and there. So that means that if theta is between 0 degrees and up to 90, right, so just that first quadrant here, and also from 270 over to 360, then in that range, cos of theta is also positive. So this is like quadrants 1 and 4, right? Cos of theta is positive there. And last but not least, tan. So for tan, what you have to remember is that tan of theta is sine of theta divided by cos of theta. So if I look in quadrant 1 here, sine of theta is positive, cos of theta is also positive, so positive divided by a positive will make a positive. Tan will be positive there. If I go over to quadrant 2, then sine of theta is positive, but cos of theta is negative. A positive number divided by a negative number will always be a negative number, so tan must be negative there. Quadrant 3 here, sine is positive, sine is negative, sorry, cos is also negative. Tan is a negative divided by a negative then. Negative over a negative would make a positive. Tan will be positive there. And then in the last quadrant, quadrant 4 here, sine is negative, cos is positive. A negative over a positive is going to make a negative, so tan will be negative there. So what you have is sine is positive on top, negative on the bottom. Cos is positive over here on the right side, negative on the left side. And tan is positive in quadrants 1 and 3.